It's my pleasure, my honor to introduce our first speaker at this conference. Martin Nowak is a professor of mathematics and biology at Harvard University. He is a leading researcher in the areas of theoretical and evolutionary biology. He has proposed that cooperation is the third fundamental principle of evolution, alongside mutation and natural selection. His work has helped to create fields such as evolutionary dynamics, virus dynamics, mathematical oncology, and evolution of cooperation. He has published more than 500 papers and 6 books. Martin has given many public lectures for diverse audiences. Before coming to Harvard in 2003, he held professorships at the University of Oxford and at the Institute for Advanced Study in Princeton. His 2 most recent books, which are entitled Beyond and Within, were contemplative studies of questions that arise at the interface of science, philosophy, and religion. So that's what he wrote for me officially to read to you. I had the pleasure of hearing Martin speak at 2 SCS conferences on the topics of evolution, of cooperation, and on mathematics. And ever since I heard those talks, I was so excited and inspired that I couldn't wait to invite him to speak to us in New Mexico. We tried to get him here in person, but that didn't quite work out, but we did bring him to you virtually so you can hear his talk. And I want to add as a personal note in my short history of my personal interactions with Martin, I've been greatly inspired by the example of how he practices his faith in his professional life and how he sees the charitable spirit with which he sees the goodness in other people, which is so refreshing in a field where I'm used to cynicism and pessimism. But Martin is truly a bright light of optimism and Christian charity. And it's our great honor to hear him speak about whether mathematics leads us to God. Go ahead, Martin.
Thank you, Chris. Thank you for this kind introduction. It's a very great joy for me to be in New Mexico with you in Los Alamos. And I have been in New Mexico and in Los Alamos several times before. And I have good connections. And Rui Ribeiro, who is in the audience, is a graduate student of mine from Oxford. And for example, David Krakauer, who is the president of the Santa Fe Institute, was my postdoc in Oxford and came with me to Princeton and then to Santa Fe via Michigan. So the title of my talk is, Does Mathematics Lead Us to God? And so that's what I want to argue basically in the affirmative, that if we really think about the role of mathematics in the world, we have made a step toward God. And so I mean this in the following way, as an argument for the existence of God, as an answer to the question, what is God? So I think mathematics actually helps us toward reflecting on this question, what God actually is, but as an experience and also as a worldview. And I want to discuss all of those in the talk with you today. And I hope you have many questions for me afterwards. So I start with a quote from our illustrious president. Even if there were no created things, there would still be the infinite and internal realm of intelligibles that we call mathematics. The infinite and eternal act of intelligence that fully grasps that realm is God. And that, I think, is a very beautiful quote from Stephen Barr, and I think it sets the stage for what we want to discuss here. So even if there was no creation, there would still be a mathematics. And then, if there was this mathematics, there's this infinite, eternal act of grasping that. And who else can do that than God? So here, how it starts, from a more skeptical perspective, when I'm having discussions with people who are around me in the scientific environment, in Harvard or elsewhere, a very common worldview that I would encounter is really that science explains everything. And the material world is all there is. So many modern people in our time, it kind of goes without saying. Science is an ultimate explanation eventually of everything. And also the material world is the only thing there is. And in philosophy, you could call these views materialism or physicalism or naturalism. So this is actually a widespread perspective in our society, and to question that view makes you look somewhat weird in many circles, but I want to question that view. So because my first question for that worldview is, what about mathematics? If you say that science explains everything, it is obvious that science does not explain mathematics. Mathematical truth is not a material object. Science studies material objects and it does experiments about material objects, but mathematical truth is something different. Science does not explain why there are infinitely many prime numbers. Science does not explain the great theorems of mathematics. The theorems of mathematics, once they are proven, they don't need a scientist to take measurements. They are not subject to empirical verification. So in that sense, mathematics for the finding of truth does not need science. I should admit, of course, that mathematics is often inspired by science. So we do kind of a study of mathematics that is informed by the world in which we live in and by what physicists want from us and so on. But mathematical truth itself is not a subject of physics. Then I can turn the question around. Does science need mathematics? And the answer is yes, absolutely. The best possible science is always the most mathematical one. Plato and Aristotle held mathematics in high regard. But for them, still higher was intuition of the forms themselves. Augustine, very interestingly, distinguishes between an opinion and an intelligible object. And an opinion is a statement or some kind of knowledge that you have about the material world. So all that you know about the material world is for Augustine an opinion. But there is something beyond that, and that is, for example, a mathematical truth. And this is what he calls an intelligible object. And once you understand a mathematical fact, you understand it by a criterion that is operating within you. And then suddenly you realize, oh, I understand how this theory works, and I understand why this is true. You have judged it by something that is operating inside you and is not subject to sensation that comes from the outside world. So by the time you understand mathematics, the teacher has become irrelevant. So you don't understand mathematics as long as you need the authority of the teacher. The teacher who has explained mathematical facts, then once you grasp it, is in the background because you are judging it by a criterion that is inside you. Augustine calls this the doctrine of divine illumination. So he says God is the teacher operating within the soul. For Kepler, a mathematical formula implies a physical reality. This was a step forward. So for many people like Plato and Aristotle, mathematics was special, but it was almost like the trick of a magician that you do in order to get some correct answer about something. Kepler was the first one who really said that mathematical formula implies a physical reality. For Galileo, the laws of nature, he talks about the laws of nature, but he means physics are written in the language of mathematics. Newton says hypothesis non fingo. This is actually very important. When he had a mathematical equation for gravity, he briefly paused and asked himself whether he takes away from the greatness of God now, simply by the fact that he can describe gravity with a formula. And he says, hypothesis non fingo, no, I do not take away from the greatness of God because I make no hypothesis as to why there is gravity. My equation doesn't say why there is gravity, it just describes gravity. But why there is gravity, that's up to God. For Newton. And Eugene Wigner, of course, wrote an important essay that is called The Unreasonable Effectiveness of Mathematics in the Natural Sciences, but again, he means just in physics. Whenever physicists need to know something, then they turn around, and very often it is the case that mathematicians have already a theory that is applicable in that scenario. But only now we begin to realize that mathematics is also the language of biology and all of science, and very soon all of knowledge. This is where I want to go with my proposal that mathematics is everything. Mathematics describes what it means to have a formal understanding of something in every field. All processes, all events in the material world are guided by mathematical objects. By this I mean the laws of nature. The temporal material world is guided by an atemporal immaterial truth. So once you realize this, you have made a step toward God. So that person who originally said the material world is the only thing there is, if that person now were to admit that actually it's like this, that the material world is guided by an atemporal, unchanging and immaterial truth, that for me is the first step toward God. And here I would almost say I can rest my case, because the rest is for you to fill in. But now you admit the presence of something extremely divine, an unchanging realm that guides the unfolding in the material world. So for this, I actually hold the view that mathematical objects are causally active in the world. So a mathematical object like an equation or a number causes events in the world. For example, it instantiates a law of nature, or it causes a mathematician to be happy who discovered something about that, or who gets a salary. Most philosophers don't actually go in that way, and I think that the reason is because they have a different model of causation. So the normal model of causation is all based on spatial interaction, but mathematics causes in a different way. And for me, that's a kind of divine action. So we have to ask, what is mathematics? And there are various attempts to describe that, and you could say it's the study of structure, space, and change. It's the logic of shape, quantity, and arrangement. Mathematics explores numbers, sets, curves, manifolds, patterns, probabilities, processes. But also mathematics is a formal language. And also mathematics is a game. And this game has rules about manipulating expressions. And this is called formalism. And that was actually proposed by David Hilbert. And David Hilbert was one of the greatest mathematicians of the 20th century. And with that statement, it almost seems it's a game that we are playing. It's a game that we are inventing. And then when they asked him whether that was actually his thought, he said, no, absolutely not. There is just one way to play that game. The game is absolutely given. And that makes him, again, a complete Platonist. We will come to that in a moment. But David Hilbert also, he revolutionized many fields of mathematics, but he was also very ambitious for all of mathematics, and he proposed something that was called Hilbert's program. And Hilbert's program essentially says, let us formalize all of mathematics. In that formalization, I demand completeness. So I want that mathematicians can prove that all true statements can be proven in that system. So the system of mathematics that we are now formulating in terms of Hilbert's program should have the property that it can prove all true statements in that system. So then the next thing that Hilbert asks is consistency. And there should not be any contradictions, because if there were contradictions in that system, that is bad news. So a contradiction would be that a system of mathematics proves a statement as true, and it proves the opposite of the statement as true. And that makes no sense. That's a contradiction. So that shouldn't be. He also demands conservation, and conservation means essentially that you cannot use much more complicated levels of infinity in order to prove something about lower levels of infinity, essentially. And he also wants decidability. So there should be a formal algorithm that should decide the truth or falsity of any mathematical statement. So this is perhaps the most ambitious program to put all of mathematics on a certain foundation. And in approximately 1931, Hilbert received a distinction and in a town in Germany, and he gave a talk. And in that talk, he made the famous statement, wir müssen wissen, wir werden wissen. And this means we must know and we shall know. So he was very optimistic that Hilbert's program will be achieved and that we know that mathematics gives us ultimate truth. And the amusing thing is that a few days before Hilbert got that prize and made that distinction, a young Austrian mathematician gave a talk very near this German city at a conference. Hilbert was not at this conference. And at that conference, this person spoke. And he showed actually that even elementary axiomatic systems, such as piano arithmetic, are either self-contradicting or contain logical propositions that are impossible to prove or disprove within that system. So he already had a formal proof available that what Hilbert wanted cannot be achieved. And that proof applies to systems that are actually elementary, so such as the foundation of arithmetics. And so then the statement is they're either self-contradictory, because if they're self-contradictory, you can prove everything, and it's opposite, so it means nothing. But if they're not self-contradictory, then certain logical propositions are impossible to prove or disprove within that system. So the system is incomplete. And Hilbert actually lived 9 years after the publication of Gödel's work, and he never responded to it. So we actually don't know what exactly he thought about this discovery, which now, of course, is judged as one of the greatest in the history of mathematics. So Gödel tells us essentially that there is no finite system that can describe the language of all true statements of second-order logic. Second-order logic are statements where you can say for all sets there exists a smallest element or something like this. So if you want to have something that is rich enough to talk about very basic things about sets and numbers, there is no finite system that can describe the set of all correct statements of that system. So there is no grammar. There is no grammar for the language of mathematics. The language of mathematics defined as the set of correct statements of at least second-order logic. But the amazing thing is, this just means we will never be done with mathematics. So it will never be that mathematicians reach a point where we say, now we have it, this contains all of mathematics. It's quite the opposite. We are constantly on a mountain that goes uphill, and we always have to climb higher. And actually, a priest in Austria once told me, that is very beautiful, because this is exactly what we would expect from dealing with God, who is an infinite being. There will never be a point of completely understanding God, an infinite being. And that somehow is supported by Gödel's theorem. Something that I ask myself often, if mathematics is absolutely foundational, if everything in the universe is mathematics, why is mathematics difficult? And I think the answer is really with this image here. This is the interior of St. Stephen's Cathedral in Vienna. We can think of it like this. In front of us is this cathedral of infinity. And there's this little ant, we are this ant, and we are climbing around in this cathedral, and all we can do is to climb around so that from one place to the next. And our mission is to understand the structure, but also understand the purpose, what is going on in here, why does this building exist, what do people do in this building? And that is actually a very difficult task. So I think we are confronted with the infinite beauty of God, but we are a very small, finite mind. Therefore, mathematics is actually difficult. Let me talk a few moments about the philosophy of mathematics, which has a long tradition. So the philosophy of mathematics recognizes that there are 3 marks of transcendence. So mathematics somehow is transcendent beyond the material world. And these 3 marks are called necessity, a priority, and human mind independence. So necessity is this idea that mathematics had to be like that. So when we look at the mathematical theorem, for example, the infinitely many prime numbers, there are 5 Platonic solids in 3 dimensions. The more we think about it, the more we come to this conclusion that it could not be otherwise. Then the next thing is a priority. Once you understand the concepts, you can basically do it from an armchair. There is no need to check back with the empirical world, and you can prove a mathematical theorem. But also it's independent of our human mind. And this is somehow the clear idea that we do not invent mathematics, we discover it. So these are the 3 marks of transcendence, and within the philosophy of mathematics, of course, they are challenged and sort of they are debated by different approaches. So there are roughly 4 approaches in the philosophy of mathematics, but these apply to all of worldviews. So this, what is being discussed here about mathematics applies to the whole world. And these are called realism, immanent realism, conceptualism, and nominalism. And realism, that is Plato's perspective. Immanent realism is Aristotle's perspective. So realism is that the Platonic forms have a real existence. Mathematics, of course, is such a Platonic form. Mathematics consists of those Platonic forms. But Aristotle, the student of Plato, always wanted to disagree with his teacher, so he denies this independent existence of the forms. Aristotle agrees with Plato in that there is no understanding without forms. So forms are absolutely essential, but they reside in matter. So they are immanent in matter, therefore immanent realism. So realism means mathematical objects exist. They are abstract. This means they're not in matter, they're not in time, they are not in a certain location. And they're independent of human activity. They are independent of any event in the material world. And so the causation between mathematics and the objects goes one way. And this is again, as in God causes the creation, but the creation does not cause God. Mathematics causes events in the world, but not the other way around. Mathematical objects are independent of any event in the material world. So this is Plato's perspective. Then Aristotle's perspective is mathematical objects exist, the Platonic forms exist, but they are in matter. And if, for example, all red objects in the universe were to disappear, then the form red would no longer exist for Aristotle. So the counter-argument is mathematical objects such as sets or infinity are not in matter. And that is widely accepted by philosophers of mathematics, that mathematicians actually for a long time have been talking about objects that cannot possibly be seen as being instantiated in matter. And therefore, immanent realism is no longer a widely accepted position or possibility in the philosophy of mathematics. So then there's conceptualism, and conceptualism means mathematical objects exist, but they are in our brain. So kind of we are making that stuff up, and the whole thing exists only in our brain. So the argument against this, mostly given by the German logician Gottlob Frege, is actually finding mathematical truth is not an empirical study to see what is in our brain. If all humans were to disappear, then mathematical objects would still exist. So essentially, when a mathematician wants to know whether a prime number exists between two very large numbers, then you do not conduct an empirical study whether you can find such an object in the brain of mathematicians. That is not how mathematical truth is being discovered. So the denial here, it does not deny that mathematicians don't have ideas of mathematics in their brain, but mathematics itself is not about those ideas, not about those concepts. It's about something that is beyond that. And of course, if all humans were to disappear, then mathematical objects would still exist. 2 plus 2 would still be 4. Again, widely accepted by analytical philosophers. But there's the last view, and this is nominalism. And nominalism is mathematical objects do not exist. They are just names which we give. They're phenomenalism. So we call something a prime number. We call something the number pi, but it doesn't actually exist. And the amusing thing is that that worldview has to be further defined by saying if those things were to exist, they would be abstract objects. So they don't live in matter. They're not in the brain. It's just that they don't exist. So these are really the two positions that people can hold these days in the philosophy of mathematics. Realism, so mathematics is real, it exists in this Platonic heaven. Or nominalism, it doesn't even exist, it's just something that people talk about essentially. But a strong argument against nominalism is so-called ontological commitment, and this is from the Harvard philosopher Willard Quine, who was a Platonist when it came to mathematics. So the sentence S is 13 is a prime number. All of us agree that that sentence is true, but that sentence can only be true if 13 exists. So it is not possible to say the sentence is true and to deny the existence of the mathematical object 13. So then nominalists have to be somewhat inventive to get out of that. So they reply, there is a language of mathematics LM and a language of philosophy LP. And the sentence S is true in one language, but in the other language, the sentence S does not occur, only it occurs the sentence S is true. That's a statement in the language of philosophy. So this is their way to get around ontological commitment without denying that mathematicians actually know what they're talking about. But again, the argument against this is that Lm is also a mathematical object, and so is Lb and metamathematics. So everything becomes a mathematical object. And it's very hard to imagine a language of philosophy that does not contain a mathematical object. So, of course, I'm very strongly committed to mathematical Platonism. But here is an argument against mathematical Platonism. And this argument comes from the field of metaphysics that is called epistemology. If mathematical objects are abstract, they are not in space and not in time. But human beings are entirely in space and time. Therefore, human beings cannot attain knowledge of mathematical objects. But human beings have mathematical objects. Therefore, mathematical Platonism cannot be true. This is a challenge against mathematical Platonism, and you have to go through all these propositions, and then you have to pick out the one that you do not accept. And I guess all of you can actually see where we are going, because what I would contest is the statement number 2. Human beings are entirely in space and time. I think that's not true. And therefore, this becomes an argument against materialism. And that goes like this: mathematical objects are not in space and not in time. Humans have some mathematical knowledge, like an ant. Thus, humans are not only in space and time. Again, mathematics has now liberated us from this confinement in a completely material existence. So the idea is the ant that understands aspects of the cathedral has the cathedral within it. Therefore, taking this mathematics now, we come to another worldview. There is an atemporal immaterial world in addition to the temporal material world. And the first guides the second, and we participate in both. This is a very different worldview, and very important as bringing somehow the skeptical world that we find ourselves in toward God. So science studies the material world of change as it follows immaterial, unchanging mathematical laws. Science studies secondary causes by choice. Science does not disprove primary or final causes. So primary cause, something that comes from, Aristotle talks about a primary cause, and he means God, an unmoved mover, of course. And final cause is also the ultimate purpose of the human life or of the universe. So in our Catholic worldview, and this is based on Thomas Aquinas, we say that God admits true secondary causes, and these secondary causes can be natural or voluntary, but both must be traced back to God. So everything that is done by God. This is how Thomas Aquinas puts it. So everything that is done by God, but God uses real secondary causes. If everything was done by God without secondary causes, that would be called occasionalism. And that is not something that Aquinas actually subscribes to. So there's some true meaning in our participation in the creation. So now I want to talk a bit about the reverse question, whether in addition to mathematics also science can actually lead us to God. And what does science tell us in big terms? So the universe had a beginning. The universe is aging. That's actually pretty recent. Only the 20th century came to these conclusions. Fewer stars will be born in the future, and planet formation is peaking now. The observable universe is a sphere around us. We are in the center of that sphere. Each observer has her own sphere. It's very funny, science has put us again into the center of the universe, actually. The size of the observable universe is 10 to the 27 meters. It's 93 billion light years. We can actually talk about this, why it is 93 billion light years when the Big Bang happened 13.8 billion years ago. In that observable universe, we count 10 to the 80 hadrons. We count 10 to the 22 stars and 10 to the 11 galaxies. again, remember, we're only talking about the observable universe, not the actual universe. Some physicists have estimated that the actual universe is maybe 10 to the 20, 10 to the 100 times larger than the observable universe, but we don't know. In our observable universe, in our galaxy, we estimate 1 billion Earth-like planets. And because of the number of galaxies around us, we estimate 10 to the 20 Earth-like planets in the observable universe. So if life and intelligent life are robust scientific phenomena, which I think they are, we would find many, many planets in our observable universe where a talk like this is happening right now. On Earth, we find 10 to the 30 cells. So there are more cells on Earth than stars in heaven, also more than sand corns on Earth. And the funny thing is, if you put all the DNA on Earth together in one long line, you get a number that is 10 times larger than the diameter of the observable universe. Physicists tell us that there are 4 forces of nature: gravity, strong force, weak force, and electromagnetic force. And strong, weak, and electromagnetic are unified in the standard model, and gravity is sort of not yet unified with those, which is kind of an embarrassment because physicists want one theory for everything, but we don't have it yet. And then the mass energy content of the universe is also somewhat mysterious because we have only 4% baryonic matter. That is essentially everything that we really study and we really understand. But this is sort of dwarfed by 28% dark matter, which is somehow necessary to explain the gravitational fields of galaxies, but it does not interact with electromagnetic radiation. And then you need this dark energy to explain why galaxies are accelerating away from each other. And that is, again, much larger than the dark matter and the baryonic matter. So we only actually, in terms of mass energy content, understand 4% of the universe. And this is the time scale. These are a few dates that are really worthwhile to mention. So the Big Bang happened 13.8 billion years ago. Sun, Earth, Moon formed 4.6 billion years. There was presumably an origin of life on Earth. It could also have been that we were fertilized by bacterial spores who came here accidentally. But if there was an origin of life on Earth, it might have happened about 4 billion years ago, because by 3.5 billion years, it was a world covered in bacteria. Everybody except 3.5 billion years. And eukaryotes came into existence 1.8 billion years ago, complex multicellularity 600 million years ago, and human language maybe 1 million years ago. And there are 3 great origins actually in the scientific unfolding. There's the origin of the universe, giving rise to physics and chemistry. There's the origin of life, giving rise to biology. And there's the origin of language, giving rise to philosophy, mathematics, poetry, everything that we are doing here now. For me, these are the 3 great origins that are actually in the scientific narrative. And the origin of language is as big as the origin of life and as big as the origin of the universe. And this is from a paper that I wrote with Andy Knoll in 2017. It's a summary of the evolutionary trajectory of life on Earth. There are these eons of Earth's history, the Hadean, the Archean, Proterozoic, Phanerozoic, and that started 4.567 billion years ago when Earth was formed. And then the last 600 million years are expanded here with somehow the animal evolving and colonizing land and so. But I also point out these mass extinctions. There are 5 mass extinctions that we know in the archaeological record. But right now we are causing the 6th mass extinction, which is very sad, of course. But the interesting theory that we propose in that paper is that these big events in evolution, it is not that evolution needed time to come up with those things. Evolution was ready, and the geophysics of the planet actually called for those things to come into existence at the time when they came. And this was mostly a consequence of oxygen levels rising, because cyanobacteria started to produce oxygen about here, but the planet accumulated oxygen in large levels when the first continents were forming, and then when the supercontinent broke up. And this can explain the macroscopic pattern of evolution of life on Earth. So the idea here is that evolution is ready. It's just the condition for it has not yet arrived before the planet is ready. So the classical view of evolution is that there are two fundamental forces, mutation and selection. And my proposal is that there are actually three fundamental principles, mutation, selection, and cooperation. So mutation means that the errors cause new types to emerge. This could be a petri dish or so, and then one cell is sort of different from the others. Selection means that different types grow at different rates. And cooperation means that there is a helping a cooperation among the organisms, among cells, for example, to form higher levels of adaptation. So these cells would start to help each other and they would come closer and closer in this association, and then they might form a multicellular organism. So cooperation, in my theory, is the master architect of evolution. It is necessary for pre-life, which is that which gives rise to the origin of life. It is necessary for protocells, cells, genomes, cellular organelles, eukaryotes, multicellularity, animal societies, and human language. So it is cooperation that leads to higher levels of biological organization and not competition. This is very important because if evolution was only competition, this is a terrible worldview. And this is, in fact, the worldview that the modern world has to a large extent, or the 20th century had, and it led to conflicts between nations. For, in some sense, the idea of evolution and natural selection was applied to nations for space. And so it is very important to make the point that cooperation is a fundamental principle of evolution, because then the world looks very different. Because then you can say our ancestors were not the most ruthless ones, the ones that killed everybody else. Our ancestors were also those that helped each other and helped others more than others. So it was cooperation from the beginning. And the great discoveries of evolution are impossible without cooperation. And in the human realm, cooperation is a preparation for altruism, for agape, and for love. So cooperation means helping others, even if they're competitors, and that can be difficult sometimes. And it means paying a cost for others to have a benefit. But on the positive side, winning strategies of cooperation are actually generous, hopeful, and forgiving. And that is something that comes out of many studies in that field, that if you want to win in this game of cooperation, you have to be hopeful in the sense that you hope that you can establish a lot of good interactions with many people. You can also forgive them for mistakes that occasionally occur, but you're also generous in the sense that you don't insist on winning. So does evolution lead us to God is a question we can ask in this realm. And I would answer that evolution and the forces of physics cooperate, and they bring about awareness of God. And if you look up in the galaxy, we can say the stars seed the universe with prayer. So the stars produce the chemical elements which are needed for the origin of life, but then the stars also provide the energy for life to proliferate. And life ultimately discovers intelligent life. And as soon as you have intelligent life, the first thing that people do is they start to look up to God, they start to pray. So I think it should not be Homo sapiens, it should be Homo spiritualis. So we can also ask the question, does the universe have a purpose? Because many modern scientists would want to say the universe has no purpose. But the universe has a purpose. And the purpose of human life is to find God by love. Plato, Aristotle, Augustine, Aquinas all realized that only God can make us happy, can bring ultimate joy. And therefore God is the purpose of life. And awareness of God changes everything. So as Chris has mentioned, I have written these books. So everything that I have said up to now, you can read up also in those books. One was published in 2024, one in 2025. And they are also journeys, they are prayer-like meditations kind of on the way to God. And I don't know how I came to write them, but whenever I get up in the morning, the first thing is that I do my writing on those books. And for me, this is a prayer-like activity. And the first book called Beyond, because beyond the veil of confusion, of selfishness, the world looks very different. So I argue in this book that we are too much concerned with the worries about our ego. So we mistake kind of the role that we are playing in this world with our true self, with our true purpose, and this causes us pain. And if we move beyond this, then you actually look at a world that is very different, that is very beautiful. So you can begin to see the infinite beauty of God in science, in mathematics, in music, in poetry, in love, and in every pair of eyes that is looking at you, especially because God is present in every human being. And the form of the good becomes your guide out of the cave of shadows, Plato's cave of shadows. And the form of the good was for Plato the highest form. And in that book, sort of the way how I describe it is that this form leads you out of the cave of shadows. And the cover image is Botticelli's lesser known Turin Venus. So this is not the famous iconic Venus of the Uffizi, but it's a later painting that is in Torino. Actually, once it came to Boston, and it was described as Botticelli's search for the divine. And the second book, God is Waiting for Us Within. This, of course, is a statement of Saint Augustine, but also of Teresa of Avila. The book is very much devoted to the Carmelite saints, Teresa of Avila, John of the Cross, and Teresa of Lisieux. So God is waiting for us within as a lover and as a beloved, as a teacher of science, mathematics, philosophy, and of life. So the human soul is really the cathedral of infinity, an infinite library of meaning, and every book in that library is an expression of God's love. So this book here is a journey through an infinitely large library, and that library stands for the human soul. And the human being is a compound of body and soul, so we are in both this material world and in the immaterial world. And as the Catholic Church teaches us, we are destined to become a temple of the Spirit in the body of Christ. This is our purpose. And I end with three quotes that move me very much, and one is in the book. This is St. John of the Cross, and of course this is the famous drawing of John of the Cross, which has mystified artists because no artist before him has ever seen the representation of Jesus on the cross like this. So this was a completely new perspective from a divine inspiration. And John of the Cross writes in one of his lesser known poems, and this is the Father speaking to the Son in the Trinity: "My Son, your company alone contents me. Whatever pleases me, I love that thing in you. Whoever resembles you the most satisfies me the most. Whoever is like you in nothing will find nothing in me." For me, this is as far as the judgment of God goes, and not further. So whoever resembles Jesus in nothing will find nothing in God. And this is a statement from Father Trisani. He is a servant of God. The canonization process is sort of underway. And he said, "I will just say that for a true person, the Lord is everything. The Lord is the mystery from which everything flows in its totality in every instant." And the last slide is from Saint Teresa of Lisieux. She said, "In the heart of the Church, my mother, I will be love, and thus I will be all things as my desire finds its direction." Thank you very much.